The next transformation we're going to do is a b transformation. So y equals sine bx or y equals cos bx. So again, we've got these four graphs done at the top here, and we're going to talk about their features. Now, I realize that this is in a different order than I put this one in, and or the one before, I wish I'd just done them in the same order, but it's okay, we can deal with it. So what we're looking at is what b affects. Now, the first thing I want you to notice is that every single one of these equations has an a value of 1. So I was going to put amplitude first. So even though this one's a negative 1, it's still a value of 1. So does the b transformation affect amplitude? No. The amplitude of every single one of these graphs is 1. But now what we're going to look at is period. So how does the b transformation affect the period of these graphs? So if you know that the period is the time for one cycle, let's take this y equals sine 4x graph and just do it in Desmos so that it's bigger. So here we go. Take off, make this bigger. It was sine, right? I'm just trying to remember. Yeah, sine. Okay. So now what we're going to do is we are going to graph y equals sine x. So y equals sine x there. And now we're going to do y equals 4 sine x. So, oops, y equals sine 4x. There you go. The black graph is y equals sine x. It has a period of 2 pi, right? An amplitude of 1. The red graph is my y equals sine 4x graph. And what do you notice about it? Well, it's definitely a horizontally shrunk graph. In other words, the time for one cycle, if you look here where it goes 0 and up, if I find another spot, it's here. This is the other place that it goes 0 up at pi by 2. So instead of this one having a period of 2 pi, it's been horizontally shrunk by a factor of a quarter, which means that 2 pi divided by 4 is now a period of pi by 2. So the next thing I want to look at is that all my key points have to happen between 0 and pi by 2. So if I took pi by 2 and I divided it by 4 or multiplied by a quarter, then all my key points are happening at pi by 8. So my first key point in my sine graph happens at pi by 8, and then at 2 pi by 8, which is pi by 4, and then at 3 pi by 8, and then at 4 pi by 8, which is pi by 2. So you're taking that whole graph of sine x, and instead of it happening between 0 and 2 pi, the whole entire cycle is happening between 0 and pi by 2. So this is a horizontal shrink. So let's put that into our note. So let's look at y equals the sine of 4x. From a period point of view, normally your period is 2 pi. But this is a horizontal shrink by a factor of a quarter, which means your period is getting divided by 4, which means now my period is happening in pi by 2. What about my key points? Well, I said that everything has to happen within pi by 2. And so if I break pi by 2 up into quarters, so if I divide by 4, multiply by a quarter, my key points are having every pi by 8. So that's going to get those 4 key points happening within a period of pi by 2. Let's look at y equals sine of negative a half x. So again, it's the graph above, but I'm just making it bigger so it's easier to see. So if we do sine of 1/2, sine of 1/2 x. Okay, what's happened here? Well, let me change my scale just so that you can see what's happened. I'm going to make us go up to 4 pi. Okay, so the black graph is my y equals sine x graph. It starts at 0, one complete cycle happens in 2 pi. The red graph is my y equals 1/2 sine x graph. Well, let's look how long it takes for one cycle. So let's find the 0 and up part again. So I'm traveling along. Oop, there's my first key point at pi. My next key point is happening here at 2 pi. My next key point is happening here at 3 pi. And in fact, a complete cycle takes all the way here to 4 pi. It's been horizontally stretched so that the period is now 4 pi instead of 2 pi. All right, let's put that into our notes. So when my graph is y equals sine negative a half x, the period, instead of being 2 pi, is being stretched by 2, and it's now 4 pi. Stretching by 2 is the same as dividing by a half. So what we're going to be looking at is that to find the period of anything, you can take the period 2 pi, which is the period of any sine or cosine curve, and divide by the absolute value of b. So for this one, we did 2 pi divided by 4. For this one, I should actually rewrite this just to be consistent. I was thinking that as soon as I wrote it. To do 2 pi divided by a half, which is the same as 2 pi times 2, which is 4 pi. Okay, so what about your key points? Well, there's 4 key points that have to happen between 0 and 4 pi. So if I do 4 pi divided by 4, then my key points are going to happen every pi. All right, one thing I didn't mention is the negative, so let's go back to that graph for a sec. So what did the negative do to my graph? Well, if you think about a sine x graph, okay, let's take out the 1/2 just for now. So if we look at a sine x graph, we know that y equals sine x is just this red graph. If I do y equals negative sine x, what did that do to my graph? Well, it reflected the x values over the y-axis. And so if you think about it, this peak that was here gets reflected over the y-axis and happens over here at negative pi by 2. And so all of your x values get reflected over the y-axis and you get this look, which actually looks a lot like a reflection over the x-axis, but technically the way this is written is a reflection of the x values over the y-axis. Okay, but it didn't affect the period or the key points or anything. So the next graph we want to look at is y equals cos of a half x. So, you know, the sketch is above here, and you can see that it's been vertically stretched by 2. But let's try to do it just mathematically. To find the period of any graph, you do 2 pi divided by the absolute value of b. So for this case, divided by a half. Dividing by a half is the same as multiplying by 2, which makes the period of this graph 4 pi. Your key points, we have to squish 4, or not squish, we have to spread out 4 points between 0 and 4 pi. So if I take that 4 pi and divide by 4, my key points are going to happen every pi. Let's double check it with the graph. So if I put in y equals, so this time we're talking about the cos x graph, so cos x, and this time we're talking about 1/2 cos x. So you can see that my cos x graph still starts at 0, 1, but my first key point here is at pi, and then at 2 pi, and then at 3 pi, and then at 4 pi. And I get one full cycle of this cosine graph between 0 and 4 pi when we have a b value of a half. Okay, lastly, let's look at y equals negative cos of negative 2x. I want you to try to fill in period and key points. So the period is 2 pi divided by the b value, which is 2, absolute value of b, which means my period will be pi. If my key points happen with 4 points within that pi, means that every key point is going to happen at a pi by 4 interval. So let's go back to the graph and just make sure that we're good. So y equals, what was it, negative cos of negative 2x. Okay, so that's my red graph. Big differences, right? So we have a reflection of the y values over the x-axis, which means instead of my graph starting at 1, it's starting down here at negative 1. And then where's my first key point? Oh, look, pi by 4. 2 pi by 4, which is pi by 2, 3 pi by 4, 4 pi by 4. One complete cycle happens between 0 and pi. Okay, the next thing I haven't talked about in this note is this number of cycles between 0 and 2 pi. We're not going to use this a lot, but I think it is super interesting for anybody who is into physics and frequency. So when we have a b value of 4, we know we have this horizontal compression. So what we want to look at is how many cycles we now get when we compress our graph by a quarter, how many cycles we now get between 0 and 2 pi. Well, there's 1 cycle, 2 cycles, 3 cycles. We get 4 cycles. When you compress your graph horizontally, or when you horizontally shrink your graph, you get more cycles between 0 and 2 pi. In fact, it's just the b value. So for sine of negative a half x, the frequency would be a half. So if you look at it, you get half of your graph. You get 1, 2, and then up to that third key point when you have a half x. And then same thing, cos of a half x, frequency is a half. And then if you have 2x, your frequency should be 2. Let's check. So peak to peak to peak, we get 2 cycles of cos x between 0 and 2 pi. All right, one last thing I should put on here, so you know how I put this, like to find period, it's always 2 pi divided by the absolute value of b. To find the key points, just always take your period and divide by 4. All right, what about domain? Well, the domain of every single one of these graphs is going to be negative infinity to infinity, because that's not affected by this transformation. My range is negative 1 to 1 because my amplitude was not affected. All right, so which of the following characteristics will a horizontal stretch or shrink affect? Does it affect your amplitude? Nope. Does it affect your period? Yep. The period is 2 pi divided by the absolute value of b. Does it affect the domain? Nope. Range? Nope. X-intercepts? Yes, but we're not going to talk about how. And then center line? Nope. So just in summary, when the b value is greater than 1, you get a horizontal shrink of your graph. When your b value is between 0 and 1, you get a horizontal stretch. So remember, opposite as it appears. To your period, 2 pi, you're dividing by b, so it makes the opposite happen. When b is less than 0, you also get a reflection, so reflect the x values over the y-axis. Now, something that I didn't feel like is very clear in that note, and I just want to make sure that you are clear, is what these reflections, look at these horizontal reflections do, the x value reflections. So this is y equals cos x. If I do y equals cos of negative x, did anything change? Whoops, I got 2 y's in there. Cos. Red graph, black graph. As soon as I got rid of that red graph, so if I take this and I hide it, black graph, red graph, black graph, red graph. A reflection of the x values over the y-axis for a cosine graph does nothing, right? Because it is already symmetrical about that y-axis. Versus the sine x graph. The sine x graph, we did talk about this, but I just want to make sure that you guys are clear. The sine x graph, a reflection does matter in the x values over the y-axis, but it also appears as though it's a reflection of the y values over the x-axis. In other words, if I put the negative here, right, I get the exact same thing. Okay, back to the notes. Let's do some. So let's graph y equals the cos of 2x. First thing we have to figure out is what is the scale of the grid I gave you. So on a test, I will tell you what scale to use for your graph. So this one, it's 4 grid lines to get to pi, which makes my scale pi by 4. The amplitude of this graph is going to be 1. The period of this graph is going to be 2 pi divided by b. So 2 pi divided by 2 makes it a period of pi. To find the number or where your key points are going to happen, you're going to take that period and you're going to divide it by 4. So if my period is pi divided by 4, it means my key points are going to happen every pi by 4. So what I want to now figure out is how to graph that. So I want to figure out how many grid lines pi by 4 is worth. Before I do that, I'm just going to go domain is negative infinity to infinity, and range is negative 1 to 1. So up until now, I haven't even cared if this is a cosine or a sine curve, right? Filling this out is the same, whether it's cosine or sine. But what I want to now look at is that it's cos. Cos starts, unless there's an amplitude change, at 1. Okay, now to do a horizontal shrink by a half, what I want to figure out is how to fit my graph between 0 and pi. So we do that by doing a key point every pi by 4. So what we have to figure out is how many grid lines pi by 4 is. Well, the scale happens to be pi by 4, so 1 grid line is pi by 4. So my next key point is going to happen here at pi by 4, 0, and then at pi by 2, negative 1, 3 pi by 4, it's going to be 0, and at pi, it's back to 1. So then every grid line, I'm doing a key point, meaning I'm going from 1 to 0 to negative 1, back to 0 to 1. So now I can connect these dots. And I can go in the other direction. So here, 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 one cycle, here, 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 another cycle. These are fun, right? Because it's the same pattern repeated over and over and over again. And that's y equals cos of 2x. So this time I didn't draw my cosec graph, but if you wanted to, if it's going to help you just see that horizontal shrink, your cosec graph starts at 1, but it has key points every pi by 2. So it's over here, it's over here, it's over here, it's up here. So this dotted graph is my y. Oops, I don't know why I just shut up so quick there. Over here. Right? So this gray graph, which you can barely see, let me just trace over top. This gray graph is my y equals cosec graph, and the blue graph is y equals 2 cosec, which is that graph compressed by a half. So every x value got divided by 2. And you can look at that in terms of grid lines, and it did it as well. Okay, the next thing I want you to do is y equals sine of a third x. So see if you can fill out all this information before starting the graph. If you get stuck, don't worry, you can always unpause. I'm going to go through this first and then I'm going to put it on the grid. But see if you can figure out as much as you can over here. Okay, so the first thing is the scale. Well, this graph has a scale of between 0 and pi, right? There's 2 grid lines, so my scale is pi by 2. So when I'm asking scale here, it's just scale of the given grid. On a test, I will tell you the scale to use. The amplitude is 1. The period, so remember, period is 2 pi by b, so it's going to be 2 pi divided by a third. In other words, I'm going to be doing 2 pi times 3. This is a horizontal stretch by a factor of 3, which makes my period 6 pi. So my cycle is going to happen between 0 and 6 pi. My key points, I have to fit 4 key points between 0 and 6 pi. So my key points are going to happen every 3 pi by 2. Remember, so the key points is period divided by 4. So what I want to figure out is how many grid lines is 3 pi by 2. So there's a couple ways of doing that. In class, students were like, hey, you could do 3 pi by 2 divided by your scale, which is pi by 2, which means 3 pi by 2 times 2 over pi. And then I would simplify, right? Pi divided by pi, 2 divided by 2, it's 3 grid lines. Or you can just look, right? This is 1 pi by 2, 2 pi by 2, 3 pi by 2 is 3 grid lines. Totally up to you. Domain is going to be negative infinity to infinity, and we haven't played with the range yet, so it's negative 1 to 1. Okay, so how do we graph this? Well, sine x graph starts at 0, 0. Nothing has changed that, so we're still going to start at 0, 0. My amplitude is 1. And my key points are going to happen every 3 pi by 2, so every 3 grid lines. So in 3 grid lines, 1, 2, 3, I'm going to go up to 1. 3 more grid lines, 1, 2, 3, I'm going to go back down to 0. 3 grid lines, 1, 2, 3, I'm going to go down to negative 1. 3 grid lines, 1, 2, 3, I'm going to go back up to 0. That gets me 1 cycle of the sine graph between 0 and 6 pi. So one way of checking to make sure you did it right is that if you do the key points thing, you should end on whatever your period is, right? So since my period was 6 pi, using 3 grid lines got me there. So then I'm pretty sure I did it right. So I'm going to go the other way as well. 0, 1, 2, 3, up to 1, 1, 2, 3, back down to 0. And I'm going to connect my dots. And that is y equals sine of a third x. All right, so that is the end of the second video. This is the transformation of b.